Hello and welcome to this Curriculum Inspiration mini-lesson. I'm pleased you could join us. Today's activity comes from the topic of sequences and series. We'll be looking at the metallic numbers activity on the TI84PlusCE platform. Okay, so metallic numbers. It's one of many such free lessons or lesson plans that you can download from the Texas Instruments Australia website from the Teachers section. Just go to the website of Texas Instruments Australia, the address is on your screen now, and hit the Teachers tab, then navigate to the state and course that you are teaching. I've gone into Queensland TI84PlusCE section and Mathematics Methods, Year 11. You can see on the right the download section where you can download a zip file containing all the materials, or independently the student activity or teacher notes. Here's the student worksheet. Teacher notes is similar, but it contains the answers in red on your screen there. So let's get started. The golden ratio, fairly famous ratio throughout history, throughout art, throughout architecture, and found in many places and also in nature. But one easy place to find it is in the Fibonacci sequence, where we examine the Fibonacci sequence in the ratio between two successive terms. You see at the bottom, Tn plus 1 divided by Tn. If n is large, or approaching infinity, we have the golden ratio. In nature, this might look a little bit like a nautilus shell. If you're thinking it does, it probably does. That rectangular has proportions of the golden ratio. Let's take a look at our Fibonacci sequence. And the Fibonacci sequence itself is what's known as a second-order difference equation. That is, that each term is calculated by looking at the two terms prior to it. For example, the term 2 is the sum of the two previous terms, 1 plus 1. The term 3 is the sum of the two previous terms, 1 plus 2, and so on. Now, if I take the first two terms and go the second term divided by the first, I get the value 1. Not quite the golden ratio just yet. If I take the ratio of the next two terms, 2 divided by 1, still not quite the golden ratio. 3 over 2 is giving me 1.5. 5 over 3, 1.6 recurring, getting closer. 8 over 5, 1.6 exactly. 13 over 8, 1.625. You can see that before very long, we start to converge towards the golden ratio. 1.61 is consistent now. Did you know that you can do this also quite easily on your TI84PlusCE? Let's have a look. Now, when you turn on your TI84PlusCE and go to the home screen, we clear that out. If you press the Y equals key, generally you have the function editor. Y equals a function of x. But that's not the only way. If we press mode, you can see there is an option for different sorts of input. Functions, parametric, polar. For today I'm going to select sequence. Let's press the Y equals key again. It looks completely different because it's now set up for input of sequences. The sequences, instead of being called Y1, Y2, they're called U in terms of N, or V in terms of N, or W in terms of N. The W sequence already has an entry, which I put in earlier. We'll talk more about that later. First of all, look at the type up the top. Sequence N plus 1, or sequence N plus 2. I'm going to select sequence N plus 2 today. For the Fibonacci sequence, as we just mentioned, was a second-order difference equation. Okay, n plus 2 equals, I'm going to define it in terms of the sum of the previous two terms. So U, now it's not the alphabetic U that you see in green on your keypad, which is doubled up on the number 5, but it's the blue U, and you can see the U, the V, the W, that are second functions on the 7, 8, 9 keys respectively. So if I go second 7, I've accessed that U. Open the brackets. Now, watch what happens when I hit the variable key. Oh, it's not giving me the X this time, it's giving me the N. So UN plus U of N plus 1. Can you see that these are the two terms that immediately precede the term UN plus 2? Let's give it some starting values for the Fibonacci sequence, 1 and 1. And there we are, ready to go. In order to see the table of values, you know that table is the second function on graph. If I select second graph, there's our Fibonacci sequence. If I quit from here and go back to that empty home screen that you saw before, I can now access values like, I could do the U of let's say the 10th term. So the 10th term of the Fibonacci sequence is 55. I could also work out any other term I like. I can also look at the ratios. Here's our fraction template. I can put U 10 divided by U 9. Okay, I've got my calculator set up in decimal, otherwise I'd get a fraction. I can also go back and increase this. Let's go for U say 20 divided by U 19, and I get an improved approximation for the golden ratio. Now here's the real trick for the metallic numbers. Do you know that there's more than just a golden ratio? What's happening here is I've got the term n plus 2 defined in terms of the previous two, just added together. But I can also multiply this term here, as you can see I've done below. Let's try this. For the Vn plus 2 term, let's define that as V of n plus V, actually this time we'll go 2 times. The implied multiplication does work here. And our 2 starting numbers. And that will give us what we're referring to as the silver ratio. Down below, where instead of having 1 lot of the immediately preceding terms, or 2 lots of the immediately preceding term, I've got 3 lots. This is going to give me the bronze ratio. Again, I'm starting with 1 and 1. If I hit the equal sign here, I'll turn it on. Let's have a look at our table now. There we have it. The first column, or the first column is the number. This column here, with the golden numbers, is the golden ratio, or the Fibonacci sequence that will give us the golden ratio. The next one will give us the silver ratio, and the next one give us the bronze ratio. I've also taken the liberty of colouring the equations and numbers to make that stand out a little bit more like those particular metals. So now on the home screen, to try to work out the silver ratio, instead of the U of 10 over 9, let's modify that to the V of 10 over the V of 9. Okay, that's an interesting looking number. I think I might have seen that somewhere before. Let's do it again for a larger value. The V of 20 over the V of 19. Okay, it's looking rather familiar. Does anyone recognise perhaps part of that number? 0.41421. If you think you do, please type it into the chat now. What number is it converging to? Let's have a look back at the PowerPoint. This is the picture for the silver ratio. There's the sequence. Here are our ratios. And this is now taken from the student worksheet. In red, you have the answer, which was taken from the teacher notes. Students are asked, okay, so what's happening with these formulas? The rth term equals y over x, and the rn plus 1th term equals 2y plus x divided by y. Well, the first one, of course, represents the ratio between any consecutive terms, however x and y might be defined. And the second one does show how we've defined it in particular for this level 2 or silver sequence Fibonacci sequence. I'll give you a moment just to look at this and see what happens as n becomes very large. Do you like that substitution? You can read that further in the teacher notes and many more activities that are related to this. I'll just quickly show you this one, which is using metallic ratios from embedded fractions. If we have 1 plus the reciprocal of 1 plus 1, we will get a value. And then if we take that itself within 1 plus the reciprocal of what we just calculated, we'll get another value, and so on. Nested fractions. That's from the student worksheet. Here's the answers. Look familiar? And if we change those initial ones to 2s, we can get something else completely different. There we'll get our silver ratio. Or it could be any that we choose to like. How can we do that on the calculator? I'll just quickly show you. Whenever you do put in a value, put in the value of 1, there it is. I can now go 1 plus, let's go the reciprocal. Remember that fraction template up here? The reciprocal of, instead of putting 1, I'm going to put answer. Can you see that's the second function down here? Okay. And now every time I press enter, it's going to do another iteration of those nested fractions. Once again, I'd call that gold. Okay, I'm just going to have a quick look to see what questions you may have asked. Okay, we're just about out of time, but there is one great question here somebody has asked, how does the sequence command work? Or somebody else asked, by the way, what if the initial values in that Fibonacci sequence were changed from 1, 1 to a different pair of numbers? What would happen? Well, that's very interesting. And by the way, I did have a couple of you correctly say that the silver sequence, silver ratio, was indeed 1 plus root 2. Root 2, of course, being the 1.14, etc. Add 1 to it, and we get that silver ratio. I'll just answer that first question, and that will do us for today. The sequence command appears as a list command, so this can help with lots of aspects of your sequences and series topic. If I look in the lists, that second function on the stat key, go to the operations, can you see the fifth command there, sequence? And we've set up this variable here, this wizard. Now, I can put an expression here. The expression in mine at the moment is x. I'm going to make that say x squared, just to be a bit different. So, of course, we're still in this mode, aren't we? We can do it in terms of n, by the way. I'm going to go n squared. And do n here. And I can start with an initial value, or I can also step it by values of 1 or more. I'm just going to go with that. So what's going to happen here, the formula n squared will have, with the variable n, will start at 1. I'm going to get 10 terms of this, and what I'll end up with is the first 10 square numbers in this case. Just on the other question, what if the initial values in the Fibonacci sequence were changed from 1 and 1 to something else? What would happen? I'll let you investigate that one. I tend to think it might converge to the same things. Hope you found some value in this short curriculum inspiration. If you'd like, thank you for joining us, and may your lessons be full of inspiration.